Hi everyone, welcome back to my channel. I am Ben Suresh. So today we are going to the part 4 of thermodynamics. So let's get started. So in the before video what and all we saw about state, process, cycle, like the definitions. So we got understood with that definitions. So in this video we are going to the types of properties. So that time we saw that based on property variations we define some terms such as states, cycle, process, like that many terms we define, right? So in this video we are going to see the types of properties. So types of properties, let's move on. So in types of properties, what are properties of a system? Properties of a system are nothing but physical characteristics of the system. For example, pressure, temperature, volume, these are physical characteristics of the system, right? So these are called properties of the system. So these properties of system are classified into two types. One is the intensive properties and extensive properties. So on what basis these two types are classified? So we will have a doubt, right? It's nothing but whether the properties are dependent on mass or independent of mass. These properties are dependent on mass or independent of mass. Based on this condition, we can classify it as the two types of thermal properties as intensive properties and extensive properties. So let's move one by one. Intensive properties. What are intensive properties? Intensive properties are nothing but the properties which are independent of mass. Properties which are independent of mass. For example, pressure and temperature. Now consider this system. In the system, this consists of a mass, right? So if the system consists of a mass, this mass, now consider the system is in a temperature T and it has a pressure P, and the system consists of a mass. Now we can see that this pressure and temperature does not have direct link to the mass. We are saying pressure and temperature as a common term, right? Now for system, if you see that what pressure and temperature, these are common and it's not directly linked with mass. As these are not dependent on mass, that properties we call it as intensive properties. Intensive properties are nothing but the properties which are independent of mass. So next one, extensive properties. So the extensive properties, as you all might have know what is that. Properties which are dependent on mass. For example, volume, energy, etc. Now consider this mass. Now consider the system. In this system we have a mass. This consists of a mass. Okay. Now this mass occupies a volume. Okay, it occupies a volume, and it also consists. This mass consists of a energy. So you can see that it occupies a volume. This mass inside the inside the system, it consists of the mass. The mass occupies a volume, and that mass also consists of a possesses an energy. So it's directly linked with mass. So in here you can see the pressure and temperature. It's saying in a common term. It is said as a common for the system, and it's not directly linked to mass. But here it is directly linked to mass. So you can see the volume is possessed by the mass, energy possessed by the mass. So it's dependent on mass. So the properties which are dependent on mass, that we call it as extensive properties. So that's all. That's what we need. I need to say about the types of properties. So one more thing to note is that in so specific extensive properties are intensive properties. Okay. Now consider the examples. Now we can see that volume and energy are extensive properties. As you see in the example, volume and energy are extensive properties. Now if it is specific? What is mean by specific? Specific is nothing but for 1 kg, that means for a mass of 1 kg. So per kg, how much volume per kg of mass occupies, and how much energy per kg of mass possesses, that we call it as specific volume and specific energy. So in this you can see that it's not directly this cuts the dependence on mass, because we are going to find for only 1 kg of mass and not for the whole mass. So as the dependency is cut, we can see that these specific extensive properties such as specific volume, specific energy are not dependent on mass. That's why we call it as intensive properties. Okay, we are kind of finding only for specific mass and not for the whole mass. That's why it is called as intensive properties. That means it is not dependent on mass. So let's move on to the next one, which are homogeneous system and heterogeneous system. What is homogeneous system? Homogeneous system is nothing but a system which consists of a single phase. Okay, a system which consists of a single phase. That is, we call it as homogeneous system. Okay, what is heterogeneous system? Heterogeneous system is nothing but a system which consists of more than one phase. Okay, so let's just see to an example and you can understand it very easily. Okay, now see that A homogeneous system, I am showing the example of homogeneous. Now consider this system. In this system, this is a vessel which consists of water, right? So this water, you can see that this water is a single phase. Liquid water is a single phase. As this consists of a single phase, this we call it as homogeneous. This consists of this system, we say it as homogeneous system. Okay. Now for heterogeneous, what is heterogeneous then? Heterogeneous is nothing but simple. Now see, sand, so in this normal water, as you see before, we are going to add sand. So while adding sand, it will sediment down. So this sand and water, it's separated. So this sand, now we can see that this sand is sedimented and this is a solid. So it is a separate phase. This sand is now a separate phase, and this water, this liquid water, is a separate phase now. So you can see that two phases are formed in one system. Two phases are formed in one system. Two phases are formed. So due to this, we say it as heterogeneous, and it's not necessary because it's more than one phase, and it's not necessary that it should be two phases. So it's due to it is having more than one phase, we call it as heterogeneous system. Okay. So let's move on to the next one, which is thermodynamic equilibrium. So what is thermodynamic equilibrium? Thermodynamic equilibrium is nothing but, now within system and during interaction between system and surrounding, no change in macroscopic property take place. For in which it macroscopic, so we are focusing on which one? We are focusing on the system always. In thermodynamics, as I said before, we are only focusing on the system. Okay. So no change in macroscopic property is observed in the system. So in that case, we say that the system exists in a thermodynamic equilibrium. So I'll say it again: within system and during interaction between system and surroundings, no change is observed in the macroscopic property of the system. So so this is what we call thermodynamic equilibrium. So let's move on to the conditions for thermodynamic equilibrium to be achieved. So three conditions should be satisfied: mechanical equilibrium, chemical equilibrium, thermal equilibrium. Sorry that outside, due to the Deepavali vibes, they are breaking the crackers, so don't take it serious. Okay. Sorry for the disturbance which has caused you. I'm extremely sorry for that. So you can see that in this, so let's move on to the topic. So in this, three conditions should be satisfied for thermodynamic equilibrium to be achieved. So what and all are that? Mechanical equilibrium, chemical equilibrium, thermal equilibrium. So mechanical equilibrium. So what is mechanical equilibrium? In mechanical equilibrium, what is for that condition to be satisfied? No unbalanced force should be present. This unbalanced force, it should not be present. No unbalanced force should be present in the system. So you can see that here a force F1. We are considering two forces. Many forces can be there. We consider now two forces. Here one F force is given this side. Force is given this side. So F1 is equal to F2. So for this mechanical equilibrium to be achieved, what should be done? This F1 should be equal to F2. Then only mechanical equilibrium can be achieved. So in mechanical, what is so simple? What we need to think? Mechanical equilibrium means no unbalanced force should be there. That means the system should be in that position. It should not move here, and no unbalanced force should be there. That's mechanical equilibrium. Next is chemical equilibrium. What is chemical equilibrium? Chemical equilibrium nothing but no chemical reaction should take place. That is, transfer of matter from one place to another should not take place. That we call it as chemical equilibrium. Okay. So transfer of matter from one place to, now we can see that in this system, if the system is having more amount of quantity than the surroundings, then you can see that gradually the system will be, as water is flown in a vessel, water is being kept. When it's flown up to the level, after the maximum limit, it flows outside. So it flows out to the surroundings, right? So that we call it as chemical equilibrium. So that should not happen. Okay. So in chemical equilibrium, no chemical reaction should take place. Okay. So next one. Next is thermal equilibrium. So thermal equilibrium, to achieve this condition, what should be done? No temperature changes should be there. There should be no change in temperature. So temperature is also a macroscopic property as a system. In this system, you can see that there should not be a macroscopic change in macroscopic. That means the temperature should be constant and it should not change. So while this thing is while there is no temperature changes, thermal equilibrium is achieved. So thermodynamic equilibrium, as I said, within the system. Now if you are seeing a system, in that system, within the system, and during the interaction when the system within the system, as I mean that when the system is isolated from the surroundings, and also when the system is in interaction with the when the system is in interaction with the surroundings, no change in macroscopic properties observed in the system. That we call it as thermodynamic equilibrium. So to satisfy thermodynamic equilibrium, three conditions should be satisfied. What is that? Mechanical equilibrium, chemical equilibrium, thermal equilibrium. Okay, I hope this video was I hope so this video was very helpful for everyone. So if anyone has find help, please share to them so that they can also get understood with this. And I'm extremely sorry because of the breaking of crackers, which is because now it's Diwali time, so I tried maximum to take video, but it was not possible. So I'm really sorry for that. So I hope everyone will have liked this video. So please like this video and share this video and also subscribe this channel so that you'll be getting better videos like this. Okay? So this is Ben Suresh signing off. Bye bye. See you.